Welcome to part 2 of getting started with OAuth and OpenID Connect. In this episode, we'll go through OpenID Connect and how it relates to OAuth. My name is Jakob Ideskog and I'm an identity expert at Curity. So we'll go through what OpenID Connect is, and more specifically, the OpenID Connect code flow. And we'll see how that's different and similar to the OAuth code flow. We'll also look at the ID token by example, and look at the inner workings of the token and see how it can be used. And finally, we go through single sign-on. OpenID Connect has that nice side effect that multiple websites can single sign-on using the OpenID Connect provider. So OAuth and OpenID are two different standards built on top of each other. OAuth is defined by the IETF and OpenID is defined by the OpenID Foundation. OpenID Connect is the latest version of OpenID. OpenID 1 and 2 are obsolete and are not, OpenID Connect is not backwards compatible with those standards. OpenID Connect is actually built entirely on top of OAuth. OAuth in the core specification 6749 is a framework protocol. So it can be used on its own, but it's really meant to be built on top on. So OpenID is built on top of OAuth, and if you support OpenID Connect, you do support OAuth, but not the other way around. OpenID Connect is also possible to extend, or profile as it's called. So there are profiles of OpenID ready today, FAPI for financial grade APIs, HART for medical, and more. And there are other specifications extending OpenID Connect as well. So if we remember the problem that we were trying to solve with OAuth, we had a third-party application, we had an API, and we needed to delegate access to the application so it could reach the API on the user's behalf. But we didn't want the user to, or the app to see the user's credentials. So we introduced an authorization server that could delegate this access without revealing anything about the user to the third-party app. So the application got access to the API on the user's behalf. But what remains now is that the application doesn't know anything about who the user is. I mean, that was the whole purpose of OAuth, but that's not always useful. So with OpenID, we now have a way to communicate that information in a standards way to the applications or the clients. And one of the reasons is the applications may need to maintain their own session, especially for web applications, but also for mobile. So if we look at the example again, I mean, it may be as simple as the app need to maintain some sort of profile information. Maybe you're logged into various accounts and you need to switch accounts in the app or something like that. Or it simply wants to say, hello, John. Usually, though, it's more a session or some sort of details that the app maintains that aren't really belonging to the API. There could be logic, especially in web applications, that simply don't depend on any backend APIs. So they may need session information or user properties in order to make decisions already in the app. It's also possible with OpenID to share user information without actually sharing any personally identifiable information, or PII. You could share pseudonyms to each application. So once the user logged in, the OpenID system issues or creates a pseudonym for the user for that client. So the client will know and will always get the same pseudonym for the same user, but it won't know who the user is per se. It's also different pseudonyms for different clients, so two clients can't figure out if they're seeing the same user or not. So let's start with the OpenID Connect code flow. We have a web application in this example, and we have the resource owner as before, and we have the resource server, the API, and we have the authorization server. Now, if we want to do an OpenID Connect code flow, the authorization server becomes an OpenID Connect provider, or an OP. The endpoints still are the same. We have the authorized endpoint and the token endpoint, but it's now OpenID Connect capable. So like before, we start by the user probably clicking login, which will redirect the entire page to authorize. And like before, we send the response type equals code, client ID, my app. And now comes the difference. For an OpenID flow, we need to pass the OpenID scope. That's a predefined scope in the OpenID specification. In OAuth, there weren't any scopes defined, just the capability of scopes. But in OpenID, there are a bunch of standard scopes defined, and we'll go through some of them later in later episodes. But the OpenID scope is the primary scope that you need to be aware about. You can ask for other scopes as well, but OpenID needs to be there. So when we do that and we ask for code, then we toggle the authorization server into OpenID Connect provider mode and tell them we're doing an OpenID Connect code flow. We still can pass the state parameter. And now a second difference is we need to pass the redirect URI parameter. In OAuth, that was optional. If a client had multiple redirect URIs configured, you had to pass it in order to tell the server which one you intended to use. In OpenID, it's a mandatory parameter, so it has profiled the spec down a bit there and strictened it. So we pass the scope, OpenID, and we also make sure to pass the redirect URI. Like before, the OpenID Connect provider doesn't really know how to authenticate the user per se, so it needs to delegate that out. So in this case, we redirect to an authentication service, the user logged in somehow, and then when we're done, like before, we redirect back to the callback endpoint, the redirect URI. And like before, we pass the state and the authorization code. So we take the code and we post it to the token endpoint. And like before, we pass the grant type now being authorization code, client ID, and the secret if we use a secret for authentication. And we pass the code 1234 in there. We also need to pass the redirect URI parameter here. And that's actually true for both OAuth and OpenID, that if you pass the redirect URI as a parameter on the authorize call, you need to pass the same one to the token endpoint. The OpenID Connect provider will now verify the client ID and secret and check that the code is valid and bound to that client and start issuing tokens. So it will issue the access token and the refresh token like before, but a third token now shows up. It's the ID token. That's an OpenID Connect defined token, and you won't get that unless you run the OpenID flow. So just because we added the scope OpenID, we now got the ID token in the response here to the token endpoint. So the client now takes the ID token and can open that and understand that, okay, here's a user, John, and it could use any information in that token to create its own session. So it can validate, first of all, that that token came from the OpenID Connect provider, and it can create a session or logged in session on the client if it needs to. And then it can take the access token as before and send it to the resource server. So let's take a look at this in OAuth tools that we used last time as well. So in the environments in OAuth tools, we set it up to use our OAuth server as before, and I've configured the client my app with the secret, and it can do the code flow. So it's the same setup as last time. So let's start a code flow and use that environment. The callback is configured for that client like before, so we're going to use the client. So this time we can add any scope we want, but we need to remember to add the OpenID scope. And then we see the authorize call that we're going to do here. So I'm just going to click run and it will start the flow. So this takes us over to the authorization server, which took us to the authentication service, and I log in. Redirects back, and we see that we got a code, and this is the post that would be done to the token endpoint. And if I click redeem code, OAuth tools does that for us. So last time we got the access token and the refresh token, but since we requested the OpenID scope, we can now see that we also got the ID token. The ID token is much larger because it contains all the data. normally access tokens and refresh tokens are just opaque strings that you have to introspect to see what's inside, whereas the ID token is always on JSON Web Token format, so it contains all the data. It's by value. So in OAuth tools, you can actually see the decoded JOT below. So we can see that it has a header, it has a payload. The header has information about the token itself. How is it signed, which key was used, etc. The payload is the thing we're interested in. So we can see when does this token expire, when should it not be used before. There's usually a JSON Web Token identifier, just a unique string identifying this token. Who issued it? This is pretty important. When you validate the token, you need to see, did it come from the party that I expect it to come from? The audience, yeah, is it for me? Yeah, in an ID token, the audience is usually the client. The subject, in this case, we can actually see that the subject was pseudonym, so it's not the actual username. And then what time, this is interesting, what time did the user authenticate? So we can see that the issued at below here is when the token was issued, but auth time is when the user authenticated. So I could be single sign-on or be logged in, way back, and the auth time would then reflect that and show this authentication took place a long time ago. So if you need the information of the user, is the user in front of its computer right now or its device, then you should look at the auth time parameter. We can also see how the user logged in. That's the ACR. That's a class reference to the method or the class of methods that the user logged in with. There's more in the token that we should go through in a deeper dive into the ID token and OpenID Connect, but all these claims that we looked at here are standardized, so any ID token you see should contain these claims. And we can also finally see that the signature is valid. So how did we figure that out? Well, in OpenID, there's an endpoint called metadata. And the metadata endpoint exposes also a key endpoint where we can find the keys that are currently being used to sign things on the server, at least the public part of those keys. So if we look at the header here, we can see the parameter key ID, and it has just a value, some random value. So if we know the key endpoint of the server, we can go there and look for this key. And if we find that key, we can use that to verify the signature of this token. If we don't, we shouldn't trust this token. So I'll show that in a bit. But first, let's run the same flow manually like we did last time. So I'm going to use a private window here to make sure we're not logged in already. And I'm going to change the redirect URL to be something different so that I can catch the code manually. The client, my app here, needs to obviously have this redirect configured also, otherwise it won't be accepted. So now if I run this flow, I can once again see that I need to authenticate, come back, and I get the code. So if you remember from the previous session, the code is short-lived, so we need to be quick. So I go to postman, and now I'm going to post it to the token endpoint. So this time I also need to include the redirect URI here that matches the one that I used on the original request. And here we can see the actual response from the server. So we can once again take the ID token here, which is the only new thing from the OAuth response that we got last time. And we can go back to OAuth tools. And there's a decode JOT window that we can use. And we can say that this is an ID token. And then we'll see the same decoding again. Let's look at this key part then. How did that work? So OpenID has metadata, like I said. So under the issuer, whatever that is for your server, there's a .wellknown / OpenID configuration path if the server supports metadata that you can visit. So just visiting that will expose a long JSON document with all the endpoints and scopes and other things that this server supports. So if we look carefully here, we can find that it has a JOX URI. So if I go and visit that, JOC stands for JSON Web Key Set. I'll just do a get there. There's one key currently being used by the server, which has this ID, which was the same ID that we saw in the ID token. So if my client is smart enough, it doesn't need to know these things on beforehand. It just needs to know, where do I go and fetch the keys? And if it ever gets a key mismatch, it can go and try and see if the server has updated its keys. And if not, it has to reject the token. So let's talk about the ID token a bit. The ID token is defined in the core specification, and it's always in JSON Web Token format, or JWTs, JWTs. Access token and refresh tokens, they're not defined by OAuth in what format they're in. They can be in various formats. Whereas in OpenID, it's well defined. It also has a bunch of predefined claims. So it's not random what will be in the ID token, or it's not per system decided. There's always a minimum set of claims that should exist in the token. Another thing to know is that the ID token is intended for the client. So you shouldn't send it to the API or to some other system or use it in any other way. You should receive it, decode it, verify that it's valid and that it's for you, and use it, but not send it to someone else. So now that we have the ID token and we know how to run the code flow, let's look at how single sign-on relates to OpenID Connect. Single sign-on is really a side effect of using OpenID Connect, as you'll see here. So let's assume we have two websites, example.com and otherexample.com, and we have a login site, which is the OpenID Connect provider, login.site.com. So the resource owner visits example.com and logs in. So it gets redirected over to login.site.com, which by hook or by crook authenticates the user. When the authentication is done, an ID token is issued. Let's assume we did the code flow here without all the arrows. And a session is then created at the OpenID Connect provider. We can call it the login session or the SSO session. So a cookie is stored on login.site.com. The ID token is then passed back to example.com, which uses it to decode it and creates its own session, session number 2 for example.com. So we have a session over here, for example, which it can maintain that has a completely different lifetime than the session we have up here. They don't have to relate after this point. So the user is now logged in at example.com. If we continue the flow, later user goes to otherexample.com and it clicks login there as well. So otherexample.com redirects over to login.site.com, assuming they're using the same OpenID Connect provider. And now the session is found. So login.site.com sees that, oh, this user is already logged in. I'm just going to use that login session and issue another ID token. It's important to know this isn't the same ID token. It's a different one intended for otherexample.com instead. So otherexample.com uses that ID token, decodes it, and sees that, oh, okay, here I have a good authenticated user, and creates its own session. So the user didn't notice anything. Maybe it noted a redirect, but it was logged in immediately when it reached otherexample.com and perhaps clicked logged in. So that's how OpenID does single sign-on. And this works for mobile applications as well if you use Chrome tabs or Safari authentication session or the system browser as to run the code flow inside of. They will share the cookie jar and they will then be able to share authentication sessions via the OpenID Connect provider. So to see single sign-on in action with OpenID, we need two websites or two clients. We can use OAuth tools as the first one, and I've also created a small website that simply has a login function running on localhost. So it's on two different domains, which normally wouldn't share any sessions. In OAuth tools also, you can use this auto redeem code function, so you don't have to click the redeem code button. It will do that automatically then. So we use the settings we had before, the OpenID scope and the read scope, and we'll just click run. So it takes us to the login. I authenticate. And now we're done here. So OAuth Tools has done a login flow and is deemed login, so to speak. So let's move over to the other page. So here we're on a different domain and we should be prompted. So we click logged in and we got back right away. You saw the blink in the middle, which was the jump to the OAuth server, or the OpenID Connect provider in this case, where it detected that this user has already logged in and then immediately turned around, issued the code, and it was redeemed here for the tokens, and we could figure out who the user was. So with that quick example, we've seen how single sign-on works between websites on different domains by sharing a common OpenID provider and running the code flow each per website and then decoding the token that they get, the ID token, on each of the websites. Well, thank you for listening. Please visit curity.io for more information, or developer.curity.io for more resources. If you have any questions or thought, don't hesitate to email us or send us a tweet. Thank you.